Hey everybody, welcome back to Trial and Error. I got a project here that I should have done probably 3 years ago. Every year for the last 3 years, in the spring, I take off my front blower, I take off the front hitch that the blower mounts to, and I completely forget about the drive shaft that runs from the mid PTO output into that front hitch, and I drive off with it sitting in the ground, and of course, as you would assume, bend the drive shaft into a pretzel. And then every time we get closer to winter, I think about this thing, and I go, I gotta fix that. Well, I never fix it, so I end up putting it on and bashing it with a hammer until I can get it just straight enough to get the job done without a ton of vibration. Well, listen, after doing that 3 times now, there's no straightening this shaft out. It's just horrible. And you don't want to run them way out of balance because it puts a lot of strain on the PTO output shaft bearings, and you will start to chew them up or at least screw up the seal and get leaks and things like that. So we don't want to make a little project into a bigger project. So without wanting to go and spend I think it's $400, it's something ridiculous for this PTO shaft from Kubota, I'm going to try to take my the ends with the little universal joints on them. We're going to try to just cut those off, salvage it, and attach it to some new DOM pipe, and see if we can just make our own here with none of the right tools, because, well, that's how I roll. So what we're going to do here first is get a measurement. We'll go very end to end. 35 inches. I'm actually going to extend this now that I have the chance. We're going to extend it to 35.5 inches because I noticed when I put it in, I've got a little bit more room for thread engagement on this end, which is, splined and sleeved. So the more thread engagement is always more better. So we're going to go with that. Going to add about 3/4 of an inch of shaft extension. If only it was that easy to extend your shaft. Okay, I don't know how this is. I mean, I know it's welded, but this is a cast piece, and this is just cold rolled steel. I don't know where this ends and this starts, or where, vice versa. So I'm going to be kind of careful about cutting this off and try to see the seam if at all possible. It might be, welded to a point where I can't tell. And if that's the case, we'll just take it down to an even amount all the way around, and the name of the game here is just balance. So we're going to try to keep this thing as in balance, as centered as possible. Yep, that's going to take too long. We got to go with the grinder. I'm going to try to remember to link these guys in the description. These little Craftsman angle grinders, they're friggin' awesome. I don't like to change the ends. I'm pretty lazy, so I just bought multiple versions, or multiple of these, because they're small. They're crazy cheap. They're like 39 bucks or something, and they last. As expected, you really couldn't tell where the two parts actually met, so I didn't waste my time grinding down any more of it. If I couldn't see a line in there, I was hoping that where it sleeves on the inside, I'd be able to see a faint history of where that line was, and we could go from there, but yeah, not happening. All right, plan B. For this first cut, I just left it long or short, depending how you look at it, but I basically nowhere near where the U joint was, so I had plenty of room and be able to look in there and see how close I could get as I made progressive cuts closer and closer to the end. For the other side, I turned my brain on and remembered I had a digital angle finder, so that actually worked out much better, and these you can find cheap. I'll link this one in the description. It's really cheap, but it did a really good job of getting that squared up with the saw blade. After the initial cuts on the chop saw were as straight as I could get them, I went back to my bench grinder and we just did some more fine tuning, trying to get that surface as flat as possible, and using the digital angle finder. Once I was happy with that, I went and put a bevel, which you see me doing here, and that bevel is just a place for the weld to fill in. It's a way to get great penetration and not have your welds bulging beyond, the surface of the pipe. And actually yeah, we're good. So I made a little mark there on our shaft links, so we'll get this cut, and I'm going to rotate it and cut it a couple of times while spinning it to make sure we get a nice straight cut on this part. Can't really do that with these guys because they're floppy, but we can definitely get the pipe nice and true. And then we'll kind of tack it in place here and see how it looks, I guess. Well, that worked. I'm pretty excited. Got a nice new drive shaft that I can run over this coming spring, and we'll do this all over again. Actually, what's funny, I went probably about 3 times the thickness on the shaft because I know I'm going to do this again. But this time, I think instead of bending, it'll lift the tractor right off the ground if it digs in. So that's my hope anyway. We'll see. So this is something you can do without putting together a jig to get it all perfect. The RPM that these PTOs spin at isn't anything too insane. So if it's a little out of whack, it's okay. It's just when it gets really out of whack that becomes an issue. But as always with anything around PTOs and tractors, you have to be super careful. So if you don't know what you're doing or don't want to risk anything, just go and shell out the $400 for a new one. But for those of us that don't mind a little risk to get the reward of not having to spend, well, that's why you're here watching this. As always, everybody, thank you very much for watching. I do very much appreciate that. Please like and subscribe. If you have any comments, questions, concerns, or criticisms, throw them down in the comment section below me. Otherwise, everybody, have a great day.